The broadcast is now starting. All attendees are in listen-only mode.
Good morning or good afternoon, depending on where you're located. Welcome to today's webinar. Today we'll be talking about our plugin software, also known as an API or DLL. Today on the phone, we have myself. My name is Jeremy Henick. I do business development for Isograph in North America. And we have Joe Belland on the line as well. Joe does technical support and training in North America.
Hello there. Jeremy, don't forget to share your screen if you've got some slides.
Oh, can you see the screen?
Not yet. There we go. Thanks.
Okay. Sorry about that. So for today's webinar, we'll be discussing the plugin. Just a couple notes on the plugin. We have a couple options for the plugin. You can buy plugin or the DLL or API. I think oftentimes people can be a bit intimidated by the plugin because of the coding that's involved. But this would be somewhere where Isograph support, mainly Joe Belland, can help you with any questions you have. We've done a lot with the plugin and DLL over the years where we've linked outside programs, linked custom build programs, or even Visual Basic interfaces to our software products. So although it can look a little heavy when Joe gets into the program, I think people might be put off by coding sometimes. It's not as complex as you may think, and hopefully we'll kind of portray that today. But it's also something we can help you with. This is something we're very comfortable doing for clients. And just to go over which programs you can use with the plugin, you can use anything. So the plugins link to all of the products in our Reliability Workbench, our Availability Workbench, as well as the Attack Tree plus NAP software. A few quick notes on the meeting. You'll notice there's a pop-out on the side if you have not used GoToWebinar before. There's several options in there. The one that I'll personally be watching is the questions dialog. So if you have questions during the web meeting, everyone is muted, just to save from confusion and going off on tangents. So if you do have questions, please post them in the questions dialog. I'll be answering questions myself and then posting some questions to Joe that come up that might be of interest to everybody. When the web meeting's finished today, I'll do my best to convert the recording and put it up on our blog later today, latest by Monday. It's always a good reference to go back to. It'll allow you to revisit some of the steps in case you miss them or want to use them for internal training, things like that. But without further ado, I'm going to pass controls over to Joe, and he can get started with the technical portion of the web meeting.
Sure, okay. I'll start sharing my screen now, but I won't be doing much for just a few minutes. Just wanted to give a quick overview of what the plugins and the DLL are before we start showing what they can do. So DLL is a programmer term, stands for Dynamic Link Library. Sometimes you might hear the same thing referred to as an API or Application Programming Interface. What that is a method for one program to talk to another computer program. So you can have two different computer programs written by different people that talk to each other. All of Isograph software supports or has a DLL interface, meaning a third-party tool, one of your own or something that someone else has written, can talk to Reliability Workbench or to Availability Workbench, any of our Isograph tools. And that can be for things such as getting data out of a project, putting data into a project, running the analysis, and things like that. So the DLL is basically allows you to write code that tells Reliability Workbench to do something programmatically. The plugin is very closely related to the DLL. The plugin allows you to write code within Reliability Workbench that's activated within the Reliability Workbench interface that will do some function. That function could be something like interfacing or interacting with the program, doing something with the data for your currently open project. It could be also something like calling a third-party program or opening another program and passing the data from Reliability Workbench to that other program. An example of that is an organization called Mentor Graphics has written a plugin that interfaces, or it allows you from within Reliability Workbench to open up their software and pass data back and forth. So it sounds kind of, at a high level, it might sound boring or confusing, or it doesn't give you a really clear picture. So that's why I wanted to have this little web meeting so we could show what, in details or in practical terms, what you can do with that plugin. So probably the best way to start would just be with a simple. I'll just start with a simple example of what you can do. So if you've ever taken the fault tree training, you might remember me talking about common cause failures. I'll talk about common pitfalls to avoid. One of the things I talk about is accidentally assigning the wrong common cause failure model to the wrong basic event. And then I talk about ways to avoid that. And sometimes I'll mention that what some users will do is color the basic events based on what common cause failure model is attached. It makes it a little more visually apparent when you have some basic events are green, some are blue, some are yellow, correlating to which common cause failure model is attached. And that makes it very visually apparent to someone looking at the tree where the common cause failure groups are. Inevitably, someone at the training will always ask, can the software do that automatically for me? Can it just automatically color my events as I attach common cause failure models? And I always answer no, but I should really actually add a caveat on that. No, but you could do that quite simply with a plugin. So that's exactly what I've done here. I wrote a very simple plugin that will color the basic events in the fault tree according to which common cause failure model is attached to the basic event. To access a plugin, when you have a plugins license, you can just access the plugins menu, and it has a list of these are the different plugins that I've created or attached within Reliability Workbench. One of my plugins I call Choose Common Cause Failure Colors. What this will do is it pops open a little dialog showing all of the common cause failure models within the project. You can see the CCF models there are listed here as well. For each one, I can just pick it and choose a color. It's opening up a standard Windows color selector dialog. So I can say, oh, my sensors are yellow, my valves will be green, and my pumps will be maybe a light blue color, or actually let's go with the lavender. And it colors them to show them the appropriate colors here. When I click OK, I'll go through the project and apply those colors to the basic events. And what you'll notice, and this is what I was trying to demonstrate in the training, is that you can see here I've actually accidentally made a mistake. I have this pump in the valve common cause failure group. It wasn't obvious before, but now that they're colored, you can see I did something wrong there. The other way we talk about in the training is if you go to the view options, you can show the CCF model IDs. You can see, sure enough, I attached the valve common cause failure model to the pump accidentally. So I can correct that by dragging and dropping the pump CCF model. Now, it won't update immediately or automatically. It won't update the colors. It only updates when I call that code, when I run that code. So I wrote a separate menu option to just apply the colors. So I click that, and it goes through and reapplies the colors automatically. So this is an example of one thing that can be done with the plugin, adding a feature to the program that isn't currently there. This one was actually fairly simple to create. If you're wondering about the time investment for creating some of these plugins, I'd say start to finish, this one took me less than an hour to develop. We can actually take a look under the hood and see how this is working. If I go to the application options within Reliability Workbench, and then I go to the plugins tab, here's a list of the different plugins I've added. So I open my CCF color plugin. We can edit it. And on the code tab, this is the code. Let me expand this a little bit. written in C# that I'm using to accomplish this these color changes. As you can see, there's really not a whole lot to it. Basically, what it's doing is it's looking at the common cause failure model table from Reliability Workbench. It passes that to a little dialog box that I wrote separately in Visual Studio, a little dialog box to handle the color picker. And to update the event colors, there's a little control loop right here that updates the event colors. What it's doing is it's just cycling through every single event in the project, looking at the CCF model that's attached, finding the color associated with that CCF model, and then applying that color to the background color of the basic event. It's just a few simple lines of code that will accomplish all that for all the events in the project. Again, it might seem, if you're not familiar with code, if you're not familiar with C#, it might seem a little daunting at first, but it's pretty straightforward. C# is an easy language to use. Okay. Again, this is one of those things, as Jeremy mentioned, where we can help you out if you're not sure how Reliability Workbench stores data, or what table values you need to look up. Okay. So that's basically all we have to do there, and it's adding this new feature to the tool. One more thing I wanted to mention. Let me go back to that plugin code. It's the way it handles this is via a field called the external reference field. There's actually a field in Reliability Workbench. Every table, every record has it, and it's specifically for use with the DLL and plugins. The external reference field is never visible within the user interface itself. There's never a dialog you open in Reliability Workbench that shows the external reference field, but it's this extra little field that can only be accessed through the DLL, and the whole point of it is just to store whatever data you want to about those items. So I'm using the external reference field in the common cause failure model dialog to store the color that I'm using. So that's what this little bit of line of code here is it stores the colors to the common cause failure model's external reference field. Okay, that's just a little DLL hint. Let's take a look at another feature, another extra feature that I've played around with. Actually, let me open up a different project for this one. I should have my fault-free cooling projects. Okay, for this one, let's talk about another feature. We'll talk about units. This is something else that comes up from time to time. You'll notice, in Reliability Workbench, the unit settings, the default is unspecified consistent. You can change that and say my failure rates are in hours, my mean times to repair are in something else. If you're familiar with the program, you know how you can set your units. Every once in a while, someone will ask about setting units individually at basic events, at the basic event level. So they want this basic event to have the units in years, this other basic event to have the units in hours, this other event to have the units in millions of hours. I think we tried that once. The problem was it got so confusing. And it became very easy to make mistakes where users would accidentally enter the wrong units in the wrong place, and they'd be getting the wrong results. And I think it ended up interfering with what people perceived to be the accuracy of the program, because it would be very easy to make these simple little mistakes. So it's not something that we want to adopt within the tool, because it's there's a potential for tripping you up. However, if it is something that you really do want, that is also something that can be accomplished via a plugin. So in this particular example, I have created a new plugin called Failure Model Plus. Basically, it mimics the failure model dialog and allows you to specify not only the failure model properties, but the units. So let me take a look at opening that up. I open it, and it looks like the failure models table. I can either show all the events or all the failure models in the project. So I can expand this. There's a list of all the basic events, and it shows whether or not it's using red failure model. So let me pick that heat exchanger and edit the failure model. Right now it's using a rate model, but there's no specified units. In this particular project, I think everything is in years. So that failure rate of 0.01 is 0.01 failures per year, or mean time to failure of about 100 years. Let me go ahead and specify that. For the repair rate, 100 repairs per year is not a very natural unit. It'd be a little tricky. Well, 100 repairs per year, it ends up being about a repair every 3.5 days. So let me go ahead and change that. I'll change it to the rate MTTR model, and enter my repair rate as 3.65 days. So now what this little plugin that I've written is going to do is it's going to convert whatever I enter here, it's going to convert to a standard unit or fixed unit for within Reliability Workbench. So I click OK there, and I'll close my, my plugin, and it updates the heat exchanger. You can look at the failure model for it, and it's converted when I entered everything. It converts everything to hours basically. So everything will be consistent for within Reliability Workbench for running the analysis. But when I'm inputting data, I can put it in a unit that might be a little more natural for the specific application. Let's see how I accomplished that in the plugin. Basically, what I did is you can define different units and how many hours there are per that unit. So there's 24 hours in a day, 168 hours in a week, 730 hours in a month, thereabouts. And I also did miles, because every once in a while we'll come up with a user who does, say, maintenance based on miles. I know some of our railway clients have done this. They'll say, we do maintenance on this component every 20,000 miles. Or I think also the mining industry, some of their maintenance was mileage based. And so you can convert from miles to hours based on the duty cycle. So I figured if you're driving 20,000 miles a year, it comes up to about 0.584 miles or hours per mile. So I'd allow you to define these units, and then it's just using this math that converts from whatever input units you have to a consistent unit within Reliability Workbench. And again, for this one, we can check out the plugin, although I think I hid most of the code away in the pop-up dialog in the plugin itself. And the plugin the code is very simple. It's just opening this failure models plus dialog that I wrote separately again in Visual Studio. If you're wondering about the time investment for this one, it was a little bit more. I would say probably all said and done was about 8 hours of time to create. So depending on how big the feature is, it can be a little more intensive. And actually, almost all that time was just spent trying to recreate the failure model dialog, because I was trying to get this to look exactly like the failure model dialog. So I had to spend some time and effort there. Okay, so those are two example plugins that show how you can expand the features of Reliability Workbench. You can add in a new feature to be able to make it easier to add in data or record extra information. I think this would be a good place to break for questions. Jeremy, are there any questions that you'd like me to answer?
So if say you have this set locally in your plugin dialog like you have here. Mm-hmm. If you were to append a tree from another user using default tree that had the default settings, would that create errors in the software, or would you have to go through and check that?
Okay. So if I have a plugin and I append a project from another user, okay. So the plugin, yeah.
Using default settings.
Oh, you mean like for the units, as we're talking about for the units?
Yeah.
Sure. Okay, so the way that this plugin that I just showed works is it converts everything to hours. So you enter in whatever units you're working with, and then it will convert it to either to hours or to whatever units are set in Reliability Workbench. So it converts everything into Reliability Workbench units. So if you append someone else's project, there will be no errors because it's going to convert everything to Reliability Workbench units. Yeah, it might be a good place to mention that the plugins are application specific, so they're not stored in the project itself. So if you create a project using a plugin and send that off to someone else, that other person doesn't need the plugin to see the project. They're not going to get errors, and they don't need to load the plugin to see the project. I think that becomes important with security, which I'll talk about a little bit later.
Okay, thanks.
Were there any other questions?
No, I think that's a good one for now.
Okay. Okay. So those first two, we're looking at adding features to the program that manipulated the existing data within Reliability Workbench. So basically changing the failure model data for an existing failure model, or changing colors for existing common cause failure models. Let's take a look at something that will add new data into the project. This other plugin, this next one, I call the Isograph builder. It's sort of supposed to sound like a safety integrity level style analysis. Like there's other tools such as Excellenta or ISIL solver that do something like that. So I'm calling this one Isograph builder. What this plugin will do is it will assemble a fault tree for you. It will automatically construct a fault tree based on failure rates and component types coming from an external spreadsheet. So some time ago, one of our partners, Systech, provided me with some failure rate data. And I just, wait, let me change my screen sharing. Okay. One of our partners provided me with a spreadsheet of failure data for common elements that you find in safety instrumented systems. So what I've done is I've taken a spreadsheet and I've built a plugin around it that uses this to build a fault tree. Let's take a look at how this.
I can't see your screen.
Let me see. Can you see it now? Can you see Excel?
I see. Oh yes, yes.
Okay, sorry. So here's a spreadsheet. I was trying to flip it over from showing just Reliability Workbench to showing the whole screen. So I have the Excel spreadsheet, which is a list of common elements, safety instrumented system elements, and their failure rates. So I've built a plugin to use this information to help me build fault trees, an automated fault tree constructor. So let's take a look at how this one works. Okay, so it gives you a little interface, and basically you attach the CSV file, which I think is already, oh, it's not attached yet. There it is. I open that CSV file, and why am I not getting it? Is that right? Oh, you know, it might be because it's already open. There we go. Okay, so now it's loaded all that information from that spreadsheet into my little plugin. So now I just pick the components that I want. So let's say I have maybe a couple temperature transmitters, a logic solver. Let's do a generic logic solver of some sort. I'm not really being too specific here. Maybe a couple block valves, butterfly fails to close. Okay. This also allows me to set the, so it imports that failure rate from that spreadsheet, and then also allows me to set the voting logic. So my sensors are 1 out of 2. Maybe my final elements are 2 out of 2. We have to shut down both of them. So I can set the voting logic for each group. And when I click OK, what the plugin is going to do is it's going to go through and assemble a fault tree, create all the events, all the failure models based on my selections here. So there it is. Now it's going to be, everything's a little small, hard to read, so let me zoom in. Sorry that the IDs are so small. They're long IDs, so it tends to scrunch them together. So it just essentially assembled this fault tree from my selections using using DLL calls, using functions that the Reliability Workbench DLL exposes or provides you to call. We can make this a little bit more complicated. Let me clear this one out and show how we can make the tree a little more complicated. Let's make it a little bit bigger. So now instead of just 2 pressure transmitters, we have, or instead of 2 temperature transmitters, we have 2 temperature transmitters and a pressure transmitter. So maybe this is a high redundancy system, so we have 2 PLCs. And then for the outputs, let's say we have two different ways of shutting down the flow. We can close the block valve. So we have two block valves on each line, and we also have, say, a pump power removal, pump stop, de-energize the trip on each line. So that's an alternative way we can use. So for the final elements, I can specify there's two different voting groups. So each voting group has a block valve and a pump stop. Secondly, I can also apply common cause failures. So say the sensors are all in one common cause failure, common cause group 1. The logic solvers are in their own common cause failure. And then the block valves would have their own, and the pumps would have their own common cause failure groups. I can edit the CCF beta value here, since that one isn't provided by the spreadsheet. There we go, and you'll notice it automatically sets it for the other options in the group. Now let me set my voting logic. I have 2 out of 3 logic on the sensors. My final elements are voted 2 of 2. However, each independent group is voted 1 of 2, so either a block valve or a pump on each final element train. Okay. Again, I can also go through and edit test intervals, coverages, failure rates, anything I can edit that's coming from the spreadsheet, I can edit in this table. Click OK. And in the end, it will build me my fault tree. Zoom in a little bit on that automatically. So this one, if you're wondering, took a little bit more work, because constructing a fault tree isn't exactly a trivial task, constructing it programmatically, but it is an example of something that you can do. And of course, I'm not the first one to come up with this idea. Several other users from other organizations have come up with some very sophisticated automatic fault tree construction tools using either the DLL or plugins. And it's a great way of automating this process. If you're building a lot of very similar fault trees, this can really help to speed up the process with a little bit of upfront work. For this one, we can see how the complexity of it. Even still, it's not too horribly complex. I can open up the project in Visual Studio, Microsoft Visual Studio, which is the development environment that I use. So here's that the form. This is the code for it. It's about 700 lines of code. All said and done, it took me, I don't know, 16 to 20 hours of work to put this all together. So still not something that's too difficult. And mainly I just wanted to show this. This is the code here that actually constructs the tree. It basically adds all the elements and connects them all together. Okay. So that's an example of something else you can do with the plugin or DLL, which is to actually construct a new project, add new data into the program, and construct a tree. And again, I've been showing you a fault tree. You could do this for an RBD Markov model, automatic construction of Markov models, or in Availability Workbench, construct an RCM cost hierarchy or a AVSIM block diagram as well. Speaking of AVSIM, let's jump over to that one. I've been sort of Reliability Workbench centric or fault tree centric today. So let's show how the plugins can work in other tools. As Jeremy mentioned at the very beginning, we can use plugins in any of the tools. Attack Tree and NAP as well all can use plugins. So let's take a look at an example of a plugin that I've used, that I've written for Reliability Workbench, or for Availability Workbench. And again, this is in the adding features category of plugins. If you're familiar with Reliability Workbench data linking, you know that you can, just to jump back to Reliability Workbench, link from a failure model in Reliability Workbench, data link that to an external project, right? So this failure rate for this basic event could come from an external project. That way you can link it to maybe a library file or something like that. Availability Workbench, for whatever reason, I think it's probably because it hasn't really been in demand yet, the data linking is only internal, right? You can write a data link between AVSIM and RCM cost, but it's only within one project file. Well, I've decided to expand on that and to write an external data linking that allows you, very similarly to Reliability Workbench, to data link from a failure model within AVSIM to an external file. So let me just take a look at that. If I open up my plugin, my external data links plugin, this is a list of all of the failure models within AVSIM. I can pick one of them, click the edit link, browse for an external file, pick my other file. The little green indicates that it's successfully connected. Expand it there. You can see the screen. Now you can tell that this plugin isn't quite finished. I haven't set the docking properties of the controls quite right. So then I can pick a failure model from that project. And on the left-hand side here, these values, these are the values for the failure model, this failure model in this project. These are the values for the failure model, selected failure model in the other project. I can link them together, and it will copy the data from that other project into this project. And it creates the link, again, using that external reference field. It will record the file that it's linking to. What this means, since that link is recorded within this project file, it's going to work basically. Let's open that up. You can see how it's actually changed those values and input them from the other file. Since I've recorded that, if I go and change the other file, let me open up that other one. It's right here. I'll give it a second to update. If I change this failure model here, right now it's using a Weibel data set. Let's say change that to say an exponential model. We'll just put in some random value and save it up. Save it here. When I go back to the previous model, when I use my plugin, it will go through and check the files that it's attached to, and it highlights in orange, meaning that the data is changed. The data is different from what's in this project. So if I go here and edit the data link, it will highlight again in orange the fields that have changed or are different in the source value. This works a lot like if you've used the Reliability Workbench data link. I was trying to mimic that behavior. It will show you what has changed. If I want to update it, I just click the link and close, and it will update everything and in this project with the data from the other project. Let's take a look at the failure model. And this now it's updated the distribution and the failure data. Again, this is using that external reference field to store what it's linking to, and it's also using another feature called the URL. You may have noticed this. If you go to the Tools menu, this applies to Reliability Workbench as well. There's this copy URL to clipboard, and you might be wondering, what does that do? It's specifically for DLL apps or plugins. We also use it in our data link manager. If you have the link to doors for system requirements tracking, we use that URL to create links between objects within Reliability Workbench and objects within doors. What that URL will do is it just copies a little bit of code, and let me show you. I can paste it into Notepad what that URL looks like. It's just a little bit of code, but this can uniquely identify the project file, so it gives me the complete path to the project. The object is a failure model. The ID was called a GUID, or Guaranteed Unique ID. Every object in Isograph software has a guaranteed unique ID associated with it, so that you can uniquely find it even when the ID of it changes. So if I change the ID of the failure model, I can still find it by its unique ID. So this little URL highlights or is linked to whatever I had selected right now as a failure model here. So what I'm doing via my DLL, or my little plugin, is it gets the URL. There's a DLL function call for get object URL. And I'm finding that that URL for the failure model in the file that I linked to. Okay. And then I'm recording that and saving it so I can find it again, find the same failure model for the purposes of data linking. Okay. Any questions on that so far, Jeremy?
Yeah, there's a few questions. So sure. Can you link the software to Excel or some kind of database?
Sure, yeah. So in that one, the one plugin, the Isograph builder, I was opening a spreadsheet. For linking to a database, like an Excel file or a maybe like an Access database, my C# for linking to those is a little rusty. I haven't done that, but I know it is possible. I just don't remember the controls with the code that you use. But yeah, you could link it to a database. You could use that, what I just showed, the data linking. You could have it look in a database, like an Access database for failure rates, and have it update them in your project when they change in the database. Yeah, that would be pretty simple to do. Conceptually simple, I should say.
And going back a bit, is there on the voting? Is there any limits on voting? Like, is there a 3 out of 12 limit, or is there really any limits to how many voting?
Sure. Yeah. This is a little off topic because it's not directly related to the plugins, but yeah, just to answer that, the software doesn't enforce a limit, but you will quickly run into a limit with the laws of math when you try to when your voting arrangements become too big. So if you do the math for, say, a 10 out of 20, and you're looking for all possible combinations, it's a simple calculation to do. 20 choose 10. I think you can do it in an Excel function. And what you'll find is that the number of combinations and therefore the number of cut sets increases exponentially. Increases very quickly. So while the software doesn't enforce a limit, you'll quickly run into the calculation speed limits, basically based on the number of cut sets that you're generating.
Okay, thanks, Joe.
Sure. Okay. One last thing, if all this seems a little bit intimidating, for those last two, the AWB data linking, that one, I would say my total effort was less than 8 hours on that one. So again, I'm giving you this to give you an idea of it's not a year-long project to build these plugins. It's if you have someone on your team who's reasonable as a coder. Now, I'm not a software developer by trade. It's more of a hobby. I do have a computer science degree, so I did study a little bit in college, but honestly, when I graduated, there was no such thing as the iPhone or mobile app development or anything like that. The field changes very quickly. So, so I'm not an expert in programming. I have a little bit of a background in it, and I do it a little bit for fun, but I can still do these what I hope looks like a fairly sophisticated plugin. My point is mainly that it doesn't require you to be a master programmer. You don't have to be a real whiz. If I can do it, then all it requires is a little bit of basic understanding of coding, the language and software development. So maybe that's not you. Maybe it's someone on your team is really good with writing like little Excel macros, or you have someone else that we were talking to. They write Python scripts to do things. Maybe you got someone who can do that. If you have someone, then I'd bet that they could write some pretty useful plugins pretty quickly. Now, if you don't want to do it yourself, you need a lot of help. Isograph can help you with that. That might be anything ranging from providing technical support so you get a better understanding of the layout of the software, because you do have to understand the tables, how they relate to each other, what data is stored where, how do you find that. So that one's hard. That one's the tricky part. That's one of the reasons that I was able to write some of these fairly quickly, is because I already understand the underlying data structure of the software. So Isograph will help you out with that. And we'll even sometimes go so far as to write plugins for you for a fee, usually, if you want us to do all the developments from start to finish. And I can give an example of that. If I go back to Reliability Workbench, I'll show a plugin we wrote. Actually, it started its life as a DLL, but I've recently converted it to a plugin that we wrote for another user. Wait, let me find the. There we go. There's a user that asked us to add a specific feature to the tool. And we said, well, we don't want it in the tool because it's a very, very specific feature. It's not a general interest. So we'll write it as a separate tool for you. And we, again, as I mentioned, we originally did a DLL. This was before the plugins existed, because the plugins were first added in Reliability Workbench version 12, I believe. So we wrote it before plugins were a thing. And what this feature that the user asked for was what they called a two-dimensional sensitivity analysis. If you're familiar with the special sensitivity analysis, you might know that the way it works is by changing, varying a parameter within the system and recording how that impacts the system results. So you can change the failure rate or the test interval or the repair time for a basic event and see how does that impact the top gate unavailability. Now, the special sensitivity analysis within the software only varies one item's parameters at a time. So we'll pick one basic event or one failure model and change its values. What this user wanted was what we call two-dimensional sensitivity analysis, where it's varying two items at a time. Specifically, what this is going to be used for is finding the optimal test interval combination. So we have two different groups of components with two different test intervals. In this case, we call them the inputs and the outputs to the system, or the sensors and the safety shutdown components. And we want to find just the right combination of test intervals to meet a given reliability or probability goal. So we wrote a DLL, which I will now show as a plugin to accomplish that. The way this two-dimensional sensitivity analysis works. Oh, there it comes up. Took it a second to load. So it shows me that it's by event group. I choose a different event group. So one of my event groups is the sensors. You can see the event group on the left-hand side. The other is the valves. I specify different test intervals separated by a semicolon. And I can actually, if I hover, I'll get a pop open. Should get a pop open tooltip. That's not showing. There's supposed to be a little tooltip that shows you the units you can specify. Like you put H for hours or Y for years for your test intervals. Oh, there it goes. Took it a second. Separate values with a semicolon, and you can specify a unit after the value. The way that this plugin will work is that it will create separate files for every combination. You can then use the batch analysis feature within Reliability Workbench to analyze all those projects, and then it reads them back into the plugin. And at the end, what it shows you is this table shows the probability, that's what these values are here, for each combination of test interval. So we're trying to find a specific, say, a specific value. Suppose we want to be below 0.001. We can find the longest test intervals we can use. So I would say probably right about here. Test the valves every 2 years and the sensors every 5 years, and we'll meet that reliability goal. You can export the results to a CSV spreadsheet so you can review them later. Okay. And again, this is also a DLL. And this one, since this is something that we built, I think this is something we also have available. Some of these other plugins are just little internal tools I've written for myself, and I would feel kind of bad about giving them out because they're not really debugged. I've been careful to show them so that I don't accidentally run into an unhandled exception or something like that, but I haven't really properly tested them and debugged them the way the rest of Isograph software is. This plugin actually, since it's more of a commercial product, is a little bit better tested. Okay. Just some closing remarks. Licensing, the plugins and the DLL do require licenses. It's a separate purchase license. They are separate themselves. There's a plugin license and a DLL license. The plugin license allows you to create these menu options and run your own code from within Reliability Workbench. The DLL allows you to, oops, see, that's what I'm talking about, unhandled exceptions. It's something that wasn't quite done right in my plugin. I'll just close that out. The DLL is a separate license as well, and that will allow you to write external programs that interface with Reliability Workbench. Something that's come up from time to time is security. We all remember the risks of word macro viruses. Remember that when that was a thing, or Excel macros. Like Excel has all sorts of security features that will prevent you from opening Excel files that have embedded macros. Or even, I just saw in the news the other day, Google Docs. There's been this phishing scam going out where you'll get a link to a Google Doc, and if you open it, then something asks for your Google account credentials. So there's always a risk of security with when you're talking about user-created code within a program. Well, we've somewhat alleviated that. It's not really a terribly big risk within our software because the plugins are not stored with a file. It's not like you can open some file that comes from a some fault tree file that comes from a questionable Russian server, and that the file will have some code injected into it that will hijack your computer. Because the plugins aren't stored in the files at all. They're stored in the tool itself. It's an application setting, and they can't be loaded unless you specifically add the plugin. You have to go via the application menu. You have to specifically define the plugin. You have to specifically choose which assemblies, which files you're linking to, so you can't accidentally link to a questionable executable or DLL file. You have to specifically add the code that it will be running. So it's not something you click on a bad file and your computer's hijacked. So the security is not a concern when it comes to plugins. While it does allow you to put in external code into Reliability Workbench, it doesn't happen accidentally or without your knowledge. Okay. That's about all I have. We have some time for questions. Is there any more, Jeremy?
Let me take a quick look. Yeah, I think we're about out of time, so that's probably good. Let me just switch screens here really quick. My screen, Joe?
Yes, now I can. Yeah.
So here's my contact information along with Joe's, although probably most of you already have it. We'll, as most of you know, we do educational webinars from time to time. If you have any ideas on future webinars or need any additional information on what we've covered today, feel free to contact me with any general questions, Joe with any technical questions, and we'll get right back to you. And as I mentioned, this webinar should be up on the blog later today or Monday if you need to refer back to it or share it with others. Okay? Thanks for attending today's webinar. Thanks, Joe.
Thank you.